All right, Gabe, number one, tell me what work is. Good. So it's the effort exerted on something that changes energy. And that is a really, really important distinction at the end. So it's effort exerted to change an object's energy. Okay, so it's something you do to another object that causes that other object's energy to change. Now, you're probably saying to yourself, well, what's energy? And the answer is don't worry about it. Okay? Don't worry about it. We're not there yet. We are going to talk about energy. All you need to know right now is that its energy will change. Okay? Energy is a thing. Objects have this thing. And when you do work, it causes that energy to change. So the only things that do work are the only things that change energy. So if an object's energy, what it has, stays the same, no work is done. But if an object's energy changes because of something that is done to it, then work is done. Okay? So the equation that you saw in the book is work equals force times distance. So W equals FD. Or work equals force times distance. And the unit is joules, which is the abbreviation capital J. Okay. There we go. I want you to take a look at number 2. I got 3 examples there. For each example, I want you to decide if work is being done on the object and tell me why or why not. So the first example, A. A bodybuilder lifts 1,000 pounds above his head. Is that doing work? In other words, do you think that changes an object's energy? And I know we haven't talked about energy yet, but energy is something an object has that work is done on. Do you think that stays the same, even though you don't really know what it is yet? Do you think that stays the same, or do you think that changes when he lifts it? Okay? How about when he holds it, or when gravity acts on the moon as it orbits the Earth? Another way to think about this is W equals FD. In order for there to be work, there has to be a force and a distance. If there isn't a force and a distance, then it's not going to do any work. So I want you to try those 3, A, B, and C. Just take your best guess. All you got to do is answer yes or no and give me a really short explanation as to why. Okay? Try that out for a second. Justin, let's start with you. A, the bodybuilder lifts 1,000 pounds above his head. Do you think that is an example of doing work? Yes. Yes, he does. Justin thinks he does. All right. Justin, you are right. Guys, shh. Yes, this is doing work. Justin, why do you think it's doing work? Yep. Yes. So, exerts a force over a distance. There's a type of energy called gravitational potential energy. When you lift things, you give them gravitational potential energy. So this does change its energy. You don't know that yet. That's what I'm telling you. But it does change its energy. So yes, it exerts a force over a distance that will cause an energy change. And again, this will make more sense when we get to energy, which will be later this week. But for right now, I'll tell you if the energy changes or not. Okay? Good. Barbara, what about B? Do you think the bodybuilder holding 1,000 pounds will exert work? What'd you say? Okay, no, you are correct. It does not. Why do you think it doesn't? Yes. Force only, no distance. And because there is no distance moved, there is no energy change. Okay? There's only a force, there's no distance change, and so therefore there's no energy change. All right, I want you to check your answer for C because C was super tricky. And to be honest, we haven't talked about it quite yet, so there's a good chance that the reasoning you wouldn't have known. Okay? So I'll tell you what it is. Gravity acting on the moon as it orbits the Earth, is that doing work? The answer is no. Now you might be saying to yourself, Mr. B, gravity exerts a force and the moon travels a distance. So how does that not work? Because the moon doesn't actually travel a distance with regard to the force. So here's the Earth, here's the moon, here's the force, but here's the distance. See how the distance is in a different direction than the force? The thing about this equation, W equals FD, the D and the F have to be in the same direction. Now, they can be positive or negative. They can be forward or backwards. That doesn't matter. But they have to be in the same X or Y direction. So, no, there is a force, but D is not in the same X direction as F. F and D have to be in the same or opposite direction. They can't be X and Y. Okay? So when I lift the barbell up, I'm going up with the motion and up with the force. Okay? If I'm asking about gravity, gravity's pulling down and I'm going up with the motion, that's still fine. They're in the same direction. They're up, down, but they're both in the same X or Y direction. Good. So the distance is in the wrong direction. That's why that one is not. And that will mean it does not change energy. Energy stays the same. All right, number 3. What's the difference between positive and negative work? Okay, positive work is work done with motion. Well, I'll say with the motion of the object, with the object's motion. That's positive work. Negative work is work done against the object's motion. So, when we're talking about directions, we're always talking about the direction of motion. So, F is positive if in same direction the object is moving. So if I'm going forwards but I hit the brakes, that's negative work because it's opposite direction of my motion. I'm going forward but the force is backwards. Okay? But if I hit the gas, that would be positive work because I'm hitting the gas forward, I'm going forward. And so that would be positive work. So F is positive, it's in the same direction as the moving object. Obviously, it's negative if it's opposite of that. All right, flip to the back. All right, number 4. For each of the examples, decide if work is positive or negative and explain why you decided on that answer. I did one of them already. Work the brakes do to stop a moving car. So that is negative work. And the reason I know it's negative is because F is in the opposite direction of the car's motion. I want you to try the other 3. The work you do lifting a box into the air, is that positive or negative? The work you do to kick a stationary ball, is that positive or negative? And the work gravity does to pull an acorn down, is that positive or negative? So see what you can do on that one. You think that's positive or negative? You are correct. It is positive. And why did you think it was positive?
I think my explanation is wrong.
That's all right. Try it out.
I said the same. They have like the same force, like the direction.
Yeah, the direction of motion and the force are the same. So force is in the same direction it moves. Okay, Tony, what about C? Work you do to kick a stationary soccer ball, positive or negative?
Positive.
Okay, and why? Yeah, positive, so you're going to kick in the forward direction. So F and D are same direction. All right, one more. Austin, what about D? Work that gravity does on the acorn falling down. Good. That is excellent. That is correct. This is the trickiest one. Austin, why did you think it was positive? Good. So gravity pulls down and acorn falls down. Good. I throw that one in there to mess you up just a little bit. Remember, it's not down or back. It's not down or left is negative and forwards and up is positive. It's if the force and the direction are the same for the distance. If those are the same, then it's positive. So even though gravity's pulling it down, it's pulling it down while it falls down, so that's positive. Now, gravity would do negative work when I lift it in the air. If I had said this for A, what does gravity do when you lift it? That would be negative. But gravity does positive when the object falls. Good. All right, number 5, what is power? I'm going to do this one just to get the time here quick. So power is work done over a period of time. The equation is P equals W over T. And the units are easy to remember, so you just say to yourself, what's the unit for power? And there you go. See, when you don't know on the test, you just say, what's the unit? See what? Anyway. It's Dad Joke Monday, apparently.